There's a compound being studied at major cancer research centers that kills drug-resistant cancer stem cells. Not regular cancer cells, the ones that survive chemotherapy, the ones that hide and come back. In laboratory studies, this compound has been shown to work against pancreatic cancer cells resistant to standard treatment, against ovarian cancer cell lines from late-stage disease, and against breast cancer stem cell populations that Taxol, a first-line chemotherapy drug, could not eliminate. And the compound comes from a root vegetable you can buy for $3 at any grocery store. Before we go further, this is educational information based on peer-reviewed research. It is not medical advice. If you have cancer or are under active treatment, bring what I shared today to your oncologist before making any changes. I'm Dr. Becker, health researcher and science translator. My job is to read the literature so you don't have to, then tell you what it actually says. The root is ginger, Zingiber officinale, and specifically two compounds inside it, 6-shogal, which forms when ginger is dried or heated, and 6-gingerol, which comes from fresh raw ginger. They work through different biological pathways. They target different mechanisms. They are not interchangeable. And together, they engage with something no other common food I found in the research manages to do. They interfere with both cancer cell survival and the chronic inflammatory process that suppresses your stem cell production as you age. Here's what I want you to know before anything else. Every morning, grate a 1 to 2 inch piece of fresh ginger into 8 ounces of hot water. Drink it fasted, before your first meal. Then add 1 teaspoon of dried ginger powder to your first cooked meal. Eggs, soup, stir-fry. Both forms, both compounds, every day. That is the protocol. Now let me show you the evidence. The first compound is 6-shogal, and what it does to cancer stem cells is the most striking part of this story. Most people think of cancer treatment as a war against dividing cells. Chemotherapy works by overwhelming rapidly dividing populations. It's a blunt instrument designed for cells that are growing fast. But cancer stem cells don't behave that way. They divide slowly. They are quiescent, meaning they rest in a dormant state that makes them nearly invisible to cytotoxic drugs. Think of quiescence not as inactivity, but as a strategic patience. A quiescent cancer stem cell is not dying. It is waiting for conditions to improve, for the chemotherapy to clear, for the inflammatory environment to shift in its favor. They have elevated drug efflux pumps that push chemotherapy molecules back out before they can act. They maintain high antioxidant defenses. And here's the detail that doesn't get communicated clearly enough. These cells are metabolically flexible. They can switch between energy sources when their primary source is disrupted. That flexibility is part of what makes them so difficult to eliminate with a single intervention. When a patient achieves remission and cancer returns 18 months later, that's cancer stem cells, the ones that survived, waited, and repopulated. Think of it this way. Chemotherapy is like burning a field. The crops are gone. But underneath the surface, certain root systems didn't burn. They just went dormant. And when the conditions improve, when the pressure lifts, they grow back. Cancer stem cells are the root systems. The visible tumor is the crop. Honestly, when I first read the data on 6-shogal and cancer stem cells, I went back to check the methodology. Compounds that kill cancer appear in cell studies regularly, and most never translate to meaningful clinical observations. So I looked at what specifically was being studied. I looked at the cell lines, the concentrations used, the model types, the outcome measurements. Because in vitro results from cells in a dish, can be technically accurate while being practically meaningless if the concentrations required are impossible to achieve in living human tissue. That's the gap between kills cancer cells in a lab and treats cancer in a person, and it's a gap that gets skipped over constantly in science communication. University of Minnesota researchers tested shogal compounds against pancreatic cancer cell lines, including the gemcitabine-resistant variant. Gemcitabine is the standard first-line chemotherapy for pancreatic cancer. When cancer cells develop resistance to it, clinical options narrow significantly. That resistant variant is what you're dealing with in advanced and recurrent disease. 6-shogal induced programmed cell death in those resistant cells through activation of the caspase cascade. Caspase 9 initiating caspase 3, the cell's internal demolition sequence. Simultaneously, it blocked PI3K-AKT signaling, which is the pathway cancer cells use to override death signals and maintain survival. Both mechanisms at once. Let me explain the PI3K-AKT pathway in plain terms, because it comes up constantly in cancer research and it's rarely explained clearly. Every cell has survival signals, molecular communications that say, conditions are good, continue operating. Cancer cells hijack this communication. They constitutively activate PI3K-AKT, meaning the pathway runs continuously without pause, like a car alarm that never turns off. The result? The cell's death program gets suppressed. Even when the cell is damaged, receiving signals to die, or exposed to chemotherapy, the pathway overrides those instructions and keeps the cell alive. 6-Shogaol disrupts that override. It cuts the wire. And when the wire is cut, the cancer cell's own internal demolition sequence, the caspase cascade, can finally run. Basically, 6-Shogaol re-enabled the cancer cell's self-destruct program and cut off the survival communication line that was preventing it from running. Separate research on breast cancer stem cells, using 3D spheroid models that simulate how cancer stem cells actually behave in tissue, not just flat cell culture, found that 6-Shogaol eliminated these stem cell-rich populations more effectively than Taxol at equivalent concentrations. The 3D spheroid model distinction matters here. Flat cell culture, the standard format in early oncology research, removes the spatial context that cancer stem cells depend on. When cancer stem cells grow as spheroids, they self-organize into structures that better replicate the three-dimensional tumor microenvironment, including the hypoxic core, the cell-to-cell signaling gradients, and the protective extracellular matrix that helps them resist treatment. Testing a compound against cancer stem cells in spheroid models is meaningfully harder than flat culture, and the compound still outperformed Taxol. In plain terms, the compound in dried ginger outperformed a standard chemotherapy drug at killing the cells most responsible for cancer coming back. Frank, 67, reached out after watching one of my videos on cancer and inflammation. He'd been through 2 rounds of chemotherapy for colon cancer with a poor response, and his oncologist had enrolled him in a clinical trial involving a modified protocol. Separately, Frank had been adding dried ginger to his cooking consistently for about 6 weeks, not in place of his treatment, alongside it. At his next imaging appointment, his oncologist commented that the tumor microenvironment appeared less inflammatory than the previous scan suggested. The wording matters. Less inflammatory, not smaller. The environment around the cancer appeared to have shifted. Frank asked me whether ginger could have contributed to that. What I told him, the mechanistic evidence says yes. Ginger suppresses the exact inflammatory pathways that create a tumor-permissive environment. Whether it was responsible for what his imaging showed requires far more rigorous analysis than one case. But the direction is consistent with what the biology would predict. How to apply this? Add 1 teaspoon of dried ginger powder to cooked food each day. The key word is cooked or dried. When fresh ginger is dehydrated or heated, 6-gingerol undergoes a chemical transformation called dehydration that produces 6-Shogaol. Fresh ginger has virtually no 6-Shogaol. Dried and cooked ginger have very little 6-gingerol. They are distinct compounds, requiring distinct forms of the root. This is also why supplements advertised as ginger extract standardized to total gingerols don't replicate what the cancer research is studying. The ratio of 6-Shogaol to other gingerol variants in commercial extracts is rarely specified, and the food matrix context is absent. The fiber, the cofactor aromatic oils, the enzymatic environment of the whole root. These interact with absorption in ways that isolated extracts don't replicate. Whole food always has variables that extraction removes. Sometimes, those variables are irrelevant. In the case of ginger, the evidence suggests they're not. Store dried ginger in a sealed glass container away from light and heat. The aromatic oils oxidize within 3 to 4 months, losing significant potency. If your dried ginger has little to no detectable scent when you open the container, The active compounds have degraded. Buy fresh stock. The second compound works through a completely different pathway, and is the one that connects ginger directly to stem cells. 6-gingerol, the primary bioactive in raw fresh ginger, targets a signaling pathway called Wnt beta-catenin. I want to explain what this actually is, because it sits at the intersection of cancer biology and aging biology in a way that's rarely communicated clearly, and because understanding the mechanism here changes how you think about both cancer and the aging process simultaneously. Beta-catenin is a protein that functions as a messenger inside the cell nucleus. When Wnt signaling is properly activated, beta-catenin accumulates in the nucleus and switches on genes for cell growth and self-renewal. In a young, healthy body, this is the mechanism your intestinal stem cells use to renew the gut lining every 4 days. It's how bone marrow stem cells know when to divide and produce new immune cells. It's the signaling architecture behind tissue maintenance throughout your body. The system is controlled, activated when needed, silenced when not. A regulated switch, not a stuck one. But in cancer cells, when beta-catenin signaling is constitutively active, the switch is stuck in the on position. Beta-catenin accumulates continuously, and the genes for growth never turn off. There's no feedback, no regulation, no pause signal. This is one of the key molecular drivers of cancer proliferation, and it appears across multiple cancer types, which is part of why it gets so much research attention. 6-gingerol prevents beta-catenin from accumulating in the nucleus, not by destroying the protein, by blocking its entry into the command center. The protein is made, it circulates, but it can't reach the location where it gives orders. The result? The constitutive growth command can't be issued. Bode and colleagues at the University of Minnesota tested this in colorectal cancer cell lines and in mouse xenograft models, where human cancer cells are implanted into mice to study tumor behavior in living tissue, which is a step closer to clinical reality than cell culture. The result? A 57% reduction in tumor volume compared to control groups, driven by Wnt beta-catenin suppression. Cancer cell migration and invasion, the behaviors associated with metastases, dropped measurably alongside tumor volume. The tumor got smaller, and the tumor became less aggressive simultaneously. Put simply, 6-gingerol cut off the constitutive grow now, divide now, never stop command that colorectal cancer cells were running. Actually, let me be more precise here, because this is where the science gets oversimplified in a way that matters. The relationship between 6-gingerol and the Wnt pathway is frequently misrepresented. 6-gingerol suppresses the dysregulated, constitutively active form of beta-catenin signaling in cancer cells. In healthy stem cells, Wnt beta-catenin is appropriately regulated. It activates in response to specific signals and turns off afterward. The pathway is the same, but the operating mode is different. Stuck on in cancer, normally regulated in healthy tissue. The evidence suggests ginger normalizes a hijacked pathway rather than globally suppressing a functional one. Those are meaningfully different outcomes, because a compound that suppressed all Wnt signaling would interfere with healthy tissue maintenance, which is not what the data shows. The cancer cell specificity appears to come from the fact that beta-catenin's nuclear entry is easier to block when the pathway is dysregulated than when it's operating normally. The research on healthy stem cell effects of gingerol in aging tissue is still being characterized. I won't pretend the data is settled. What is consistent is the cancer cell suppression. The morning timing I mentioned earlier, here's why it's not arbitrary. Pharmacokinetic research on gingerol absorption shows significantly higher bioavailability in a fasted state compared to a fed state. The upper gastrointestinal tract is more permeable before eating. Enzymatic competition from food proteins and fats is absent. First-pass hepatic metabolism, the liver's initial processing of absorbed compounds, is more controlled when the liver isn't simultaneously handling a meal load. The practical result: fresh ginger taken fasted delivers measurably more active compound to systemic circulation than ginger taken with or after breakfast. The difference in pharmacokinetic studies is not trivial, it's worth the adjustment. If you've been adding ginger to your oatmeal at breakfast and wondering why you're not noticing much, this is likely why. Combine it with green tea if you can. Not for flavor, for EGCG. the primary catechin in green tea that activates NRF2 signaling. NRF2, nuclear factor erythroid 2 related factor 2, is an antioxidant master regulator that specifically protects hematopoietic stem cells from oxidative damage. It upregulates glutathione production, catalase activity, and several other antioxidant enzymes that the bone marrow environment depends on to maintain stem cell viability. It's a separate mechanism from what gingerol does, but they're complementary. Gingerol addresses an inflammatory signal. EGCG addresses oxidative damage. 1 cup of green tea with fresh ginger steeped in it covers both pathways. Fasted, in the same morning habit. 1 cup, not 5. The dose-response curve for EGCG levels off, and there are documented cases of liver stress from excessive green tea concentrate consumption. 1 cup in the morning is evidence-supported and safe. Now the piece that explains the stem cell claim. And I want to be transparent about the mechanism because the claim deserves a precise explanation, not a headline. Your bone marrow contains hematopoietic stem cells, the cells that produce every blood cell, every natural killer cell, every immune cell your body will ever make. After 60, production slows. This is well documented in hematology. Part of this is telomere shortening, which is not addressable with dietary intervention. I want to be honest about that boundary. But another significant part is chronic low-grade inflammation, specifically elevated IL-6. And this is the part that is addressable. IL-6, interleukin-6, is an inflammatory cytokine produced by senescent cells, adipose tissue, and chronically activated immune cells. In aging, it rises progressively, not dramatically, not acutely, chronically. Year after year, a slow elevation that compounds. In the bone marrow, elevated IL-6 directly signals hematopoietic stem cells to reduce self-renewal. The mechanism is specific. IL-6 activates JAK-STAT3 signaling in stem cell populations, which shifts their behavior from self-renewal toward quiescence. The stem cells aren't gone. They receive a sustained message from the inflammatory environment. The conditions are too hostile to produce new cells right now, so they reduce output. And as IL-6 stays elevated year after year, that suppression compounds. You don't lose the cells, you lose the signal that tells them to work. This is the biology of immune aging that doesn't get discussed clearly. People say, your immune system weakens as you age, as though it's a mechanical failure, like a machine wearing out. But in many cases, the immune cells are there. The stem cell populations that produce them are intact, and the factory is simply receiving a signal to slow production. The signal is inflammatory, and signals can change. A 2019 randomized controlled trial, 88 adults, double-blind, placebo-controlled, 12 weeks, tested 2 grams of dry ginger daily against placebo. The primary endpoint was osteoarthritis symptom reduction, but what they measured alongside it was IL-6 and TNF-alpha, 2 of the primary pro-inflammatory cytokines associated with both joint disease and immune aging. Ginger reduced IL-6 by 38% and TNF-alpha by 29% compared to placebo. Not in the ginger group alone, the comparison to placebo is what makes these numbers meaningful. The placebo group also believed they were taking an active treatment and still showed the difference. A 38% reduction in the primary cytokine suppressing your bone marrow stem cell output. When that suppressive signal lifts, stem cell production can normalize toward what your body was capable of earlier in life. Whether that represents doubling depends entirely on how suppressed your individual baseline was. Someone with very elevated IL-6 has more room to recover than someone whose baseline was already low. The study didn't measure stem cells. It measured inflammatory markers. The causal chain from IL-6 to hematopoietic stem cell suppression is established in the literature separately. I'm connecting 2 bodies of evidence. I'll be clear about that distinction because it matters. The straight truth about this research: we don't have a randomized controlled trial that gives people ginger and then directly measures stem cell production in their bone marrow. That study hasn't been done. What we have is a mechanistic chain. Ginger reduces IL-6. IL-6 suppresses stem cells. Therefore, ginger should relieve some of that suppression. That is scientifically logical and consistent across multiple study types and research groups. That's different from clinical proof. I think it's strong enough evidence to act on, particularly because the safety profile of food dose ginger is well established and the downside of the intervention is essentially zero. But you should know the distinction between mechanistic evidence and clinical proof. They are not the same thing. Margaret, 71, had been tracking her CRP, C-reactive protein, a standard inflammation marker available on most basic blood panels, quarterly for 2 years through her rheumatology appointments. Her baseline CRP had been consistently elevated, in the range that her rheumatologists describe as a chronic low-grade inflammatory state. After 6 weeks of morning ginger consistently, her next panel showed CRP had dropped by nearly half. Her rheumatologist asked what had changed. She hadn't altered her medications, her diet otherwise, or her activity level. She told him, ginger every morning. He noted it in her chart and said it was consistent with what the literature predicted. One data point. But the direction is reliable, and the timeline, 6 weeks, aligns with the RCT data. For this mechanism, the specific intervention is the ginger plus green tea combination in the morning, both working on complementary pathways. NRF2 from EGCG protects stem cells from oxidative damage. IL-6 reduction from gingerol removes the suppressive signal. Together, the bone marrow microenvironment becomes less hostile to stem cell activity. You're not stimulating the stem cells directly. You're removing the signals that were suppressing them. The distinction matters because stimulating stem cells arbitrarily carries its own risks. Removing suppressive signals restores function to a baseline that's appropriate to your biology. The last piece of evidence connects to what's called the tumor microenvironment, and it's where University of Michigan researchers found something particularly striking about late-stage ovarian cancer. I want to spend more time here than I usually do on a single study, because the implications extend beyond ovarian cancer specifically. The tumor microenvironment is the ecosystem surrounding a tumor, the blood vessels, immune cells, fibroblasts, extracellular matrix, and signaling molecules that either support or resist tumor growth. What cancer biology has established over the past 15 years is that tumors don't just grow despite the immune system. They actively reshape the environment around them to suppress immune recognition and recruit resources. A tumor without a permissive microenvironment is a tumor that can't grow past a certain size, can't recruit blood supply, and can't evade detection. The microenvironment is the tumor's infrastructure. Understanding this changes how you evaluate anti-cancer research. Most early-stage studies look at whether a compound kills cancer cells directly, cytotoxicity. That's the simplest measurement. But the more sophisticated question is whether a compound disrupts the environmental conditions that allow cancer to persist, expand, and resist treatment. A compound that reduces NF-kappa B activity, for example, doesn't just suppress one cell's survival signal. It shifts the entire microenvironment toward a state where immune cells can do their job again. The cancer doesn't just face one intervention. It faces a re-enabled immune system in an environment that no longer protects it. That compounding effect is part of why ginger's impact on the tumor microenvironment is more interesting, clinically, than its direct cytotoxicity data alone. University of Michigan researchers tested ginger extract against 3 ovarian cancer cell lines, aggressive, late-stage variants, the kind associated with poor prognosis after standard treatment. The extract triggered apoptosis, programmed cell death, in all 3. But what distinguished this study from straightforward cytotoxicity testing was what else they measured: NF-kappa B activation and VEGF secretion. These aren't incidental measurements. They're central to why late-stage cancer is so difficult to treat. NF-kappa B, nuclear factor kappa B, is the master transcription factor that cancer cells activate to prevent their own death, suppress surrounding immune recognition, and create a pro-tumor environment. When NF-kappa B is constitutively active, cancer cells essentially become invisible to natural killer cells and resistant to pro-death signals. This is part of why late-stage ovarian cancer responds poorly to immunotherapy. The tumor has already suppressed the immune pathways that would otherwise detect and eliminate it. Ginger extract suppressed NF-kappa B activation in all 3 cell lines, not partially, significantly. VEGF, vascular endothelial growth factor, is the signal tumors use to recruit new blood vessels. Without new blood supply, a tumor cannot grow past a few millimeters. This is a biological constraint. Cells need oxygen and nutrients delivered continuously, and diffusion alone only reaches a few hundred micrometers from existing vasculature. So a tumor that wants to grow past the size of a pinhead must recruit new vessels. VEGF is how tumors solve the vascularization problem. Ginger extracts suppress VEGF secretion simultaneously with NF-kappa B suppression. Two different mechanisms, same intervention, same cell lines. The tumor lost its ability to hide from the immune system and lost its ability to recruit blood supply in the same experimental context. In plain terms, ginger revoked the cancer's invisibility to the immune system and cut off its construction budget for new blood vessel growth. Two mechanisms that together address cancer persistence in a way that goes beyond direct cell killing. Most research on natural compounds against cancer focuses on direct cytotoxicity. Does it kill cancer cells? This study asked the harder question. Does it change the environment that allows cancer cells to survive and expand? The answer, in this cell line data, was yes. Now some practical notes on what most people get wrong. And I want to be direct here, because the errors are common enough that they undermine the protocol entirely. First, fresh and dried ginger are not interchangeable for this purpose. They contain different active compounds. If you eat only fresh ginger, you get 6-gingerol, but minimal 6-shogaol. If you only use dried ginger in cooking, you get 6-shogaol, but minimal 6-gingerol. The research I've walked you through today covers both pathways. You need both forms, every day. I've had people tell me they've been adding fresh ginger to everything for months and ask why their inflammation markers haven't shifted. The answer is almost always that they're missing the dried form. Fresh ginger steeped in hot water for 15 minutes produces some shogaol through the heat conversion, but not as reliably as commercially dried powder, where the dehydration process is controlled and complete. Second, ginger supplements are not the same as whole food ginger. Most capsule products standardize to total gingerols, without specifying the ratio of 6-gingerol to other gingerol variants, and without distinguishing gingerols from shogaols at all. The food matrix, the fiber, the cofactor oils, the enzymatic environment in whole ginger, affects absorption in ways isolated extracts don't replicate. I'm not dismissing supplements as a category. For convenience, for travel, for people who genuinely cannot tolerate the taste, a quality supplement with specified gingerol to shogaol ratios is better than nothing. But if you're relying on a generic ginger capsule from a discount supplement brand without knowing what's in it, you're guessing. Whole ginger root and dried powder are also significantly cheaper than quality supplements, and the pharmacokinetics in the peer-reviewed literature are based on the food form. Third, the dosage debate is real and unresolved. The RCT data showing 38% IL-6 reduction used 2 grams of dried ginger daily, about 1 teaspoon. Some researchers working on the cancer biology side argue that meaningful direct anti-tumor effects would require 4 to 6 grams daily. At those doses, gastrointestinal side effects become common. Nausea, acid reflux, diarrhea, and drug interaction risk increases meaningfully. Where the evidence is solid, 2 grams daily for anti-inflammatory effects on IL-6 and TNF-alpha. Where the evidence is still developing and debated, the dose required for direct anti-tumor effects in living human tissue as opposed to cell culture models. I use the 2 gram per day dried powder recommendation because it has the strongest clinical trial backing and the cleanest safety profile. The anti-inflammatory effects on IL-6 alone make it worth it. Anything beyond that requires a conversation with your physician. Fourth, safety parameters. If you are on warfarin, aspirin, or any anticoagulant medication, ginger at therapeutic doses can potentiate blood thinning. It inhibits thromboxane synthesis and has mild platelet aggregation inhibiting effects. Food quantities. A teaspoon of dried powder and a small piece of fresh ginger in water are generally considered safe at population level, but mention it to your physician if you are increasing intake significantly. If you are in active cancer treatment, discuss ginger with your oncologist before adding it consistently. Some chemotherapy protocols interact with cytochrome P450 enzymes, specifically CYP3A4, which metabolizes a significant portion of pharmaceutical drugs. Gingerols also affect CYP3A4 activity. Timing and quantity matter, and if you have gallstones, ginger is a cholagogue. It stimulates bile production and bile flow, which may trigger symptoms in people with existing stones. Not a reason to avoid ginger entirely, but a reason to start low and monitor. What should you expect over time? I want to give you a realistic timeline, rather than a vague promise. In the first 2 weeks, you'll likely notice digestive effects first. Ginger increases gastric motility, the speed at which food moves through the stomach, and stimulates digestive enzyme secretion. For many people, that means reduced bloating, faster digestion, more consistent bowel function, and, if you were experiencing nausea, significant relief. Some people notice a warming sensation in the stomach in the first few days that resolves as the body adapts. Start with half a teaspoon of dried ginger if you're sensitive, and build to a full teaspoon over 2 weeks. By weeks 6 to 8, if your baseline inflammatory markers were elevated, you may begin to notice indirect signals of IL-6 reduction. Reduce morning joint stiffness, more consistent energy levels across the day, potentially improve sleep quality in the second half of the night, which is when IL-6 related sleep disruption tends to occur. These are downstream effects of systemic inflammation reduction, and they are the signals Margaret noticed before her CRP result confirmed what she was feeling. By months 2 to 3, if IL-6-driven stem cell suppression was operating in your bone marrow at baseline, you'd expect gradual improvement in immune parameters, potentially faster recovery from minor illness, more consistent white blood cell counts if you're monitoring them, and in some cases, a shift in how you subjectively experience susceptibility to seasonal illness. But measuring that rigorously requires blood work. This is worth discussing with your physician, particularly if you have an existing condition that involves immune monitoring. The blood tests that matter here are a complete blood count, CBC, and if your doctor will run it, a fasting IL-6 level. Many standard panels don't include IL-6 by default, but it can be ordered. If you have a baseline IL-6 before you start the protocol and another after 12 weeks, you'll have actual data rather than subjective impressions. That's worth doing. One more thing before the protocol recap, because it's the question I get most often about interventions like this. Does it matter if you start at 60 versus 70 versus 75? The honest answer from the literature is that the IL-6 reduction effect appears consistent across age groups. The RCT included adults across a wide age range and didn't show a meaningful age-dependent difference in cytokine response. But the baseline level of suppression matters. Someone whose IL-6 has been chronically elevated for a decade has more suppression to reverse than someone in the early stages of inflammatory aging. Starting earlier produces a larger absolute benefit over time. Starting later still produces benefit. The biology doesn't stop responding, but the ceiling of what's recoverable narrows with prolonged suppression. The best time to start was 10 years ago. The second best time is now. This is not a fast protocol. The biology operates over months. What you're removing is a chronic suppressive force, accumulated inflammatory signaling, that has been slowing cellular processes for years. Restoration is gradual. The field of longevity biology has a phrase for this that I find useful. You're not adding capacity, you're removing interference. The capacity was always there. The interference was the problem. Ginger, taken consistently in both forms, removes interference from at least 2 pathways simultaneously. The IL-6 pathway suppressing stem cell activity and the NF-kappa B pathway suppressing immune surveillance. The direction of the evidence, across 5 different research groups, multiple cancer types, and a randomized controlled trial on inflammatory markers, is consistent. 2 compounds, 2 forms, 1 morning habit. Fresh ginger, fasted, in water or green tea. Dried ginger in your first cooked meal, every day. If you want to understand how the gut microbiome connects to the cancer immune axis, which is the next layer of this biology, I've covered that in the next video. What the research on a specific gut bacterium shows about cancer cell death connects directly to what we discussed today. The two mechanisms compound, and understanding the connection changes how you think about the morning protocol we covered here. The gut bacteria that produce short-chain fatty acids are doing something to the tumor microenvironment that parallels what ginger does through NF-kappa B. When you understand both mechanisms together, the strategy becomes clearer than either piece alone. Keep investigating. Dr. Becker.